All
So
right, you can
yes,
start.
the recording has started. So now I want some of you guys to just tell me what you think should be done with the data. Like you've seen the data, you've seen there are some variables, uh, the year, each person in the data joined the year. What again is there in the data? Let me just open the CSV file. Mm. So yes, there is ID, the join date, the marital status of uh, every person, the sex, the gender, the branch code where the registered occupation category, and so on, the codes. And there are also different products, though the products are just they are also in codes somehow in different columns. So now I know everyone must have seen the data. So what do you think? Like what are the what kind of problem is this? Is it maybe before I go into what problem is it? There is in generally in machine learning there are two types of learning method. There is supervised learning and unsupervised learning. If you've not heard of that before, maybe it might be your first, but I will explain. Supervised learning is when you have uh, data and labels, right? So you have your X and Y. Y here in this case is the label, and X is the predictor, the explanatory variable. So that's a supervised learning setting whereby you want to use some set of variables to predict the other variable. So the other variable that you want to predict are like labels, right? They are like labels. And in an unsupervised setting, you just have data. So in that case, you want to do maybe only clustering or something else, not like you are predicting some set of values from another set of variables, right? So now, what kind of problem is this? This is clearly a supervised learning problem, right? Because you have some set of variables that you want to use to predict another set of variables, right? So this is a supervised learning setting. But now, maybe let me share my slide. Then we can take it from there. Yes. Can you guys see my screen now?
Yes, yes,
Good.
yes.
So please always please engage in the discussion. Just you unmute and you say something. So like I said, machine learning in general, it's the different learning method that you have is the supervised and the unsupervised. Though there might be maybe some people might argue that there's another maybe reinforcement learning or something, but just let's focus on these two things and majorly on the first one, the supervised learning method. And under supervised learning method, like I said earlier, you have a label data set. You have some sets that you want to use to predict another set of variable. So here, the popular technique here is usually regression, right? In regression model, you have two set of variables, your X and Y. You are using your X to predict your Y, right? This is what is being done in regression. Also, classification. You are also using the same X to predict Y, only that is a kind of classification setting. So they are like you have some set of classes that you want to predict using your X, right? So this is what is being done under supervised learning setting. However, for unsupervised, you have data that are not labeled, they are unlabeled. And the main technique that you use there is clustering. You just want to cluster them together. Maybe you have some let me take an example of maybe you have some portfolio or maybe description of some people, and you want to cluster them into maybe if people are of this facial look, then they are from this tribe. If they are of this facial look, then they are. So it's a kind of clustering method. But we are not going there. What I want to focus more is the label data itself under supervised learning setting. So now you have two set of variables, X and Y. And X usually the predictor, the explanatory variable, and Y is what you want to predict, the predicted, right? So now, however, the variables under each collections, the variables under them can assume different type of data type. It can assume different data type, I mean. So the data type can be nominal or categorical. Nominal means that there is no rank. Example is if you say like name, maybe there is name of in the data set, there is name of every customer. So that's like a nominal data type because there is no real rank between one customer and the other customer. It's just a kind of identity, like the IDs, just like so. That's a nominal data type. You also have categorical data type. Of course, you know that example of that is the marital status, the sex, and so on. So categorical data type, maybe you have different categories, maybe male, female, married, unmarried, and so on. And another type of data type is this discrete. Discrete are those data type that you can really count. Example might be maybe the number of application someone made in a school. Maybe how many times did you apply in the school, and so on. Different. So something that you can count, and they are usually of natural number 1, 2, 3, and so they are discrete. You also have continuous data type. Example of these are height, weight, even age. Age is also continuous because continuous are usually those data type that you can't really measure discretely. If I ask you what is your age, you just say maybe 30 or 35. But is that really your age? Because you have conditioned that age to be something yearly, but at this point in time, maybe you are not even 30, maybe you are 30 if you consider the months, the date, the hours, the microseconds, and so on. So they are usually continuous. You can't really say per se that this is it, like counting the number of oranges in a basket and so on. So it's quite different. So now I'm now going to move to the different algorithm to use if you have this different data type under your X and Y variable. Now, if you have if X, which is the predictor, the explanatory, it can assume any data type. That's fine. However, your predictor, your predicted, the Y. Oh, my slide is gone, right? Let me bring it up quickly. So I'm almost there. And I'm back up. So now your X can assume any variable. It can be a collection of different data type, different of those data type I described. It can be collections of different data types. So because not always that you have just one variable in your X, it can be as many as possible with different data type. Example is the competition you are in now. You have different set of X, and you have categorical data type there. I think you don't have continuous is there if you are talking about the age. I think there's age there, right? Is there age? Oh, bet year, something like that. Bet year. Well. So, but it doesn't really contain continuous that much. So your Y, it can be if your Y is continuous or discrete, the best algorithm to use in that case under supervised learning setting is regression. Of course, you use regression. However, if your
Yes,
y
yes,
is,
yes.
yeah, what's that? Is there a question? No question. So if your y is a label value, like it can assume labels of maybe 1 0 -1 1, different kind of labels, right? Then the best algorithm there is the classification. You want to classify your set of x into those different classes of that label, right? Because the label, we have classes. Example is maybe you collect some pictures and you label them. So the classes under that label might be maybe cat and dog, right? Cat, dog, those are the classes under that label. So your y is a label data, and it will have classes right under it. So classes of maybe cat or dog and so on. So the best algorithm there is classification. You want to classify them. Now, the tricky part now is under the same Y, your label, it can be one label. Like I said, you collect a lot of pictures of cat and dog, right? And the cat and dog, they are classes under one label. You want to classify them. They are one label, but you want to classify them. So here, the very first row here, it's a one label data set. You only have one Y, but it has two classes, cat and dog. So you want to classify the pictures into class dog or class cat. That's a label Y with two classes. So algorithm there is binary classification. An example of binary classification algorithm you might have known is logistic regression, whereby you are classifying into class 0 and 1. Maybe when you've done your encoding of the cat into 0 and dog into 1, so then logistic regression, you want to classify into class 0 or class 1. You can also do SVM. SVM is also a classification algorithm for binary classes, right? And now, you can also have one label with more than two classes, right? You can have one label with more than two classes. Who can give me an example of that? You can also take the same pictures. However, now you have maybe cat, dog, and maybe goat, or even more than that, and so many animals. So you want to categorize your pictures into different animals, right? So this is also uh, one thing you can do.
Hello, hello.
Yes.
I have a question.
Yeah, yeah. Go ahead.
Okay, okay. When you talk about OVR, like one versus all, or one versus the rest, please can you explain it with regards to multi-class classification?
Yeah, I'm coming there. I'm coming there. So now we are talking about two class. We've talked about two classes. You have your binary classification, logistic regression, or SVM. Now, if you have more than two classes now, what do you do? Maybe you can still use logistic regression, but most of this binary algorithm classification method, they have been conditioned to work best for two classes. But you can always do a workaround for it to work with more than two classes. A workaround is what Ilekura just mentioned, one versus rest, or one versus one. So let me take an example. So if you have so many pictures and you want to classify them into, let's say, uh, four classes, that's multi-class. Now your label is multi-class label, right? It's a multi-class label. Four classes of maybe red, blue, green, and yellow. Red, blue, green, and yellow. This is more than two classes, obviously. It's four classes, so they are multi-class. Then how do you apply this binary classification algorithm to this kind of problem? Then what you will do is to do this one versus all that Ido just mentioned. So you will take let's say blue, maybe class blue to be 0, and the other classes you combine them together to be just one, class. You understand what I'm saying? So now you only have 2 classes, so blue and the rest of them. So that is the meaning of 1 versus rest, or 1 versus all, or how do you OVR? Okay, 1 versus rest. So you only have 2 classes now, blue and the remaining class. Then you build your binary classification algorithm around that, blue and the rest of the class. Also, you also build another binary classification on yellow and the rest of the class, green and the rest of the class, then blue and the rest of the class. So in the end, how many classification algorithm will you have? How many binary classification algorithm will you build for that kind of problem? Anybody?
I think 4.
4. For this example is 4. So the number of binary classification algorithm under OVR, 1 versus rest, is equivalent to the number of what? The number of classes. The number of classes in your Y, right? I hope everyone get that. So the number of binary classification algorithm you are going to build now is equivalent to the number of classes you have, because you are doing 1 versus rest. I hope you get that now. Now, the problem now comes in where if you have large data sets, maybe millions, you want to build 4 classification algorithm on top of million data sets, right? That is, and you know, for every algorithm, you are going to tune the model, you are going to do model fine tuning, grid search, and so on. So you end up like having to train for a very long time. Like it requires a lot of resources, because you are building a number of models equivalent to the number of classes that you have. So that is one thing about one disadvantage or maybe downside of 1 versus rest. That is even better. There's also another method, which is 1 versus 1, OVO, 1 versus 1. And that is, in my example, you build a classification algorithm with blue versus yellow, then blue versus green, blue versus green. Then you build for yellow versus green also, and yellow versus blue, and green versus blue. So in the end, that is how many do you have? How many classification algorithm will you build for 1 versus 1 in that regards?
I think 6.
So that is 6. So to get that idea, is it how do I think it's I forgot how to, there's this calculation for it. In fact, I think combination of permutation or something. So there's no repetition. So there's one thing, like I forgot how to represent, how to know how many algorithms if you have multi classes. I think it's combination.
Yeah, permutations.
Is it permutation?
It's permutations. Yeah.
It's permutation. Yes, it's permutation. So that is maybe number of classes permutation 2, right? That's 4 permutation 2. Yes, 4 permutation 2 again. I think 4 permutation 2. So, but you get the idea now, right? So now there is another type of label type, and now this is normal multi-class. Now this is multi-label multi-class. Multi-label multi-class. What does that mean? Instead of having only one Y, you know, initially I'm talking about just you have only one Y, just one Y, but that one Y has maybe 2 or more classes under it. So you have 1 colon, but that colon can take different classes, maybe 0 or 1, or 0, 1, 2, 3, 4, depending on how many classes you have under that one label. You get that idea now, right? So, but now you might have multi-labels. Multi-labels means that you have many Ys. You have many Ys. Different class. Example is, let's say we collect, maybe you are a Netflix person, and the Netflix company want to maybe they categorize their movies into action movie, adventure movie, comedy, and those different movie types, right? Action, adventure, comedy, and maybe let me just take those three: action, comedy, and adventure movies. Now they want to predict if a user likes or don't like one of those categories, right? So now under action movie, for me, I might like all those three movie type. So now I have there is 3 Ys. The Ys are action, adventure, and comedy. So if I like all those 3, for those under that column, I'll have 1, 1, 1. 1 denoting I like, right? 1, 1, 1, which denotes I like all those 3 movies. If you, as a person, as a Netflix user, you only like maybe action movie, you don't like the remaining two labels, you have under action, you have 1, and under the remaining 2, you have 0, 0, right? So now this is a kind of example of multi-label, multi-class. So in this example, there are 3 labels, but 2 classes. 3 labels in regards for of action, adventure, and comedy. Then the 2 classes, meaning 0, 1 under each of them. It can be 0 or 1, 0 or 1, 0 or 1. So let me know. Do you get the idea of my explanation? Just unmute and let me know if you get, and if not, maybe I can explain again. Do you get the idea?
Yes.
Hello. Hello.
Yes.
Yeah, yes, we
Okay,
get
basically
I
now,
get
so
the
what
idea.
you're saying, hello,
Yeah.
hello.
Continue. I can hear you.
Okay, so basically now, like this competition now is, I think it's kind of similar to what you're saying. Like we have a multi-class and it's multi-level.
Exactly what I am trying to bring out, right? So now you see now the competition. Let me my network is still, I can't share my screen. So now this competition is very similar. The insurance the insurance company, they have different insurance category or different products under their, or let's say in different insurance category. You can insure your house, insure your car, have health insurance, and what other insurance? Maybe insure your company too. And so many types of insurance thing, right? The insurance category. Now you as a user, maybe you have and insuring something means, insuring means 1 and not insuring means 0, right? So you as a user, maybe for me, of course I want to have a car. Maybe I have a car and I need maybe a castle, even a big mansion. I have a mansion too, and I have a very big company. And what else? Of course, my health also is very important. I don't want to die now. So maybe those are the 4 categories. So I want to insure. So under housing insurance, I insure my house, that's 1. Under health, I insure my health too, that's 1, and so on, 1, 1, 1. So for me, under the different labels, the class, I will have class 1, 1, 1, 1, 1 under it. Maybe you I don't know, maybe you can afford to buy car even if one got stolen or something. You don't need to, you can just buy immediately. You don't have to. So maybe you don't want to insure your car, I don't know. Then maybe under car insurance, you have 0. Under health, you have 1. Under house, you have maybe 1, 2, and so on. So do you guys get the idea now? So this is a multi-label, multi-class. So in this competition, it's multi-label binary class, because the class is 0 or 1, right? Multi-label binary class. Now, do you all get the idea now?
Hello, hello,
Hello? Yes?
hello.
Hello, I can hear you. I can hear you.
Okay, so I get your concept clear, but there's another question I want to ask. What if under each label now, under different labels, take for instance under the action movies, we have different movie types like maybe Hollywood, and the rest, or any of the wood stuff. So basically now, so if you have different columns that corresponds to different types of movies under the same action column, can we still use multi-class and multi-label for that?
Yes, it's still multi-label, multi-class. So now
Okay.
it's not about now maybe under action. I only love action movie when it's a Hollywood movie, because Nollywood, we in Africa, we don't really perform well in action movies, right? Our action is not too convincing, right? So maybe under action movie, you have categories of the movie industries: Hollywood, Nollywood. Ghana is Bollywood. No, Ghana is Kumawood. Then which one is Bollywood? India is Bollywood. So now under that, maybe under the multi-class, I will have which one do I like? Maybe Hollywood correspond to 1, and the remaining correspond to maybe 2, 3. I don't know. You understand what I'm saying? So that is that. So now that the problem statement now, or the label data type is now clear. Now, what kind of algorithm now to use? How do we tackle multi-class, multi-label? I saw in the all 7 week in the group, in the channel, some of you are proposing maybe you build different classification algorithm for the different Ys, like that's the different labels. So under one product, you build a classification algorithm. You build another classification algorithm for another for the other product. And in the end, there are 21 products, right? So in the end, you build 21 classification algorithm. Wow, that is huge, very huge. Actually, some of these machine learning algorithm in sklearn actually support multi-label, multi-class classification problem. Random forest support this. Let me bring up my slide, because I know I tried random forest and it's there is a question in Bala. Okay. Yeah, Patrick said some like their algorithm that deal with this. So let me share my screen. Oh, I'm still I still have internet problem. So like I was saying, the random forest algorithm clearly support this. XGBoost, I think XGBoost, I don't know. XGBoost in itself as a standalone algorithm, I don't think it supports multi-label, multi-class yet. But if you are using it as an embedded classification algorithm in other sklearn module, I think it should work. But I haven't tried that. Let me bring up this again. But one thing is, maybe before my slide comes up, what are the different algorithms that you all have tried? Because I know you submitted something on Tuesday, right? Yesterday. So what did you try and you had your result, right? Of course, maybe at first I also made some submission yesterday, and my very first submission gave me 7 point something on the leaderboard. In fact, I was the second to the last on the leaderboard, and I was surprised. Well, not too surprised because I just called the model. I just made an instance of what model did I use? Decision tree, decision tree algorithm, DTA. So I just call the instance without defining any parameter. So automatically to use the default parameter. So I actually wanted to get my submission file well in order and to make sure that it works. So the decision tree algorithm with all the default parameters, nothing was added, nothing, no tuning. And even my feature engineering is not even okay because I just did one auto encoding for the sex and I think this sex and marital status. So I only use sex and marital status, the one auto encoding for sex and marital status to build the algorithm. And I made submission, so it gave 7.1, 7 point something. I did the same for random forest and it performed well, 1 point something. So, and I did another one for some complicated algorithm somewhere like that, and I had 0.6. So now I have 0.6 without any tuning, no feature engineering. I only consider sex and marital status, nothing else. And so that means if you go ahead and perform a very sophisticated feature engineering, you tune your model well, do maybe random or grid search, then you should be well like in the first maybe first 100. I think you should be in the first 100 on the leaderboard. So now let me see if I can share the screen now. So now this is up. So there is this this library which is called SK Multilearn. SK Multilearn. So though it's I don't think they have so many developers because the last version was like I think last year or 2 years ago, so it has not been updated. So, but it's majorly built for multi-label classification. So it's majorly built for multi-label classification. So using this different method, binary relevance, classifier chain, and label power set. I let me see if I let me open SK Multilearn. Let me open so there is so I just want to give an explanation of those three things, how you can use it if you want to use it. So now for the now let me go to where is it? This is not. I can't find. Oh, before I get to what I'm looking for, can you guys just give me the different algorithm you guys have tried and your results?
Okay. Hello.
Hello.
Yeah, from my own side, I use logistic regression after I applied PCA and did some visual engineering. I got about, I think, 1 point, no, 0 point something, I think 0.7. Then I tried using XGBoost with the same model that I've already applied PCA on. And I actually got a higher value, 0. I think 0.7 something. But it didn't actually reduce my accuracy and my score. So I don't know what I need to do. Maybe I'll just try other models and try this your SKLearn, multi-learn. Just see what will happen.
So when you did logistic regression, did you build logistic regression for the different label, or how
Oh,
did you
okay.
do that?
Okay, what I did was I transformed the data frame using pandas mouth to basically. So what I did was to have a column for the different products and then another column for the label. So each column represents each row has a value for the product and then a label. So it's not like a multi-class. I have to transform it to one column. So like a
Oh,
like a binary classification for the label. Yeah, but
okay.
I don't know if that is actually effective. I think I will have to go with this multi-class classification and see how it performs because the other one you just have to transform it and then it will now having different rows like for each customer. So basically now we have like maybe 5 rows for each customer, but different product and different label. So that's the thing. That's what I did.
Okay, okay,
I'll
okay.
try other method again and see what I'll get.
Okay. So I still want to hear from others, but before then, so now I've seen what I'm looking for. Now, if you want to try this library, note that the release date, the latest version here, if you can see, is 2018, December 20. That is 2 years ago, and this is not too good for a very good library. So library should be reviewed and updated like at least maybe once in 3 months, right? So this is like maybe this thing is not strong enough, so maybe they've, I don't know. But don't. I'm just saying this so that you won't base all your resources on just this library, right? Well, I just want to, because they have a very nice thing, so I just want to explain some of the things. So now, let me move. Now, this is what I'm looking for. So now, this is, oh, is this thing showing at all? Can you still see my screen?
Yes, you can see it.
I've lost connection here, so let me connect again. I'm very sorry, the internet is really bad. So almost there. And I'm back up. So now you see my screen now. So now I want to explain these three things: binary relevance, classifier chains, and label power sets. Though I might not give the best explanation because I'm also still a learner. So now for the binary relevance. So this binary relevance is doing like splitting all those different labels of the Y into independent labels. You see the first diagram here. Of course, you can see my cursor, right? The first diagram here, you have your X and you have your different labels, Y1, Y2, up to Y4, and their classes under it, right? Now, what binary relevance does is to break those Ys into independent labels, right? You can see the second diagram. So you have your X with Y1. You have another, the same X with Y2, X, Y3, and X, Y4. So it breaks this problem into sub-problems using the Ys, the labels. Then you train your classification algorithm on this. So this is not done manually. You just supply the data as it is into the classifier using binary relevance, and it does everything you want to do. Now, each of these method, the binary relevance, classifier chain, and label power sets, each of these methods, what they do is they take a classifier. So the classifier used here is Gaussian naive Bayes, naive Bayes algorithm, right? So Gaussian naive Bayes algorithm. So you can change this to maybe a random forest. You can use random forest. I use this with random forest, and that is the best score I've had so far, 0.6. Though it's actually worse on the leaderboard, but it's okay. So you can change this classifier instead of Gaussian. You can try different classifiers, random forest, decision trees, and so on and so on. Just try different. I tried to use XGBoost, but I'm getting error that I don't understand myself. So maybe you can try that and solve the error. And you fit, you predict, and that's it. So this is what binary relevance is. It splits each labels into independent labels and train a classifier on those independent labels. Now, there's also one, classifier chains. This assumes that there is a kind of dependency between different labels. That is Y1, Y2, Y3, Y4, Y5, Y4. So the first thing to do is it does it. What is that English word? It does it like one after the other by maybe joining the label one after the other until you have your full labels. So the first, you try your X and Y1, you build a classifier on that. Then knowing what you build another classifier. So it's a kind of classifier chain. You are building a kind of Markov chain. Markov chain means that the present, like there is a chain, there is a dependency between these events and the previous events, right? So this is a kind of what it does. So it builds a kind of chain between the labels, right? So you start with a classifier using X and Y1, then you join Y2 with Y1 until you've used all the labels, right? You join all the labels together, and that's what classifier chain does. And also, it also take a classifier in it here. So you can change this to maybe whatever classifier you want to use, maybe decision tree, random forest, I don't know. Label power set, though this didn't work well for me, I don't know. So, but let me just copy this. So if you want to take a look, I will send you this. If you want to take a look, if you want to just use.
Usman, a question.
Yeah.
So now for the classifier chains, so now our label target will be the products or all the products.
Yes, of course. So
Okay,
now
thank you.
I've explained. So because this competition that you are doing, the kind of problem is a multi-label classification problem, and I've explained that. I think you get that right. It's a multi-label because you have so many products. So the products there are the labels, and under each label you have 0, 1 class. It can be 0 or 1, right? So this is a multi-label problem. So I've sent the link if you want to take a look. I've sent the link, and let me also send this, which, because there's, I think there's, you can, this contain more of what can be the different modules in that library. So are there any other question?
And
The main problem
yes,
here
yes,
is,
I have a question.
okay, continue.
It's about when you now want to transform the predictions to match with the submission sample that we were given. I see it will be some kind of trick to us.
Some kind of what?
Some kind of trick. It will be tricky to us to do that. Or how did you do it?
It's not really tricky. Let me see if I can. I think I did that somewhere. Okay, let me see. Aha, so here, this is where I did that.
Okay.
You can see my screen well, right? So now what I did is, you know, you need the ID and the product code, right? The ID of every customer and the product code, right? So now
Yes.
I got the ID here. So now the ID, because you know the product code applies to every ID, right? So one ID, one person,
Yes.
one person can either apply for a product or not. So that means the ID, one ID, you can have their all the products must be under one ID. Like, I don't know how to better put that down. Or what I'm trying to say is, one ID should be permute with every product. Do you get what I'm saying now? You have to permute every ID with all the products. If you are getting me, just let me know if you get that.
Yes. Yeah, yes, we can get you.
So now, in order to combine, the first thing is, I repeat, there are 21 product codes, right? There are 21 products. So I repeated every ID 21 times. So this is what is here. I repeat the ID, all the ID 21 times, right? This is what is done. Don't mind this one, just reset the index because I have to do that and drop the index. It's giving me, so you can do that. So the first thing is repeat the ID, the number of times. Now also, you get the Y colon, which are the label, the products, right? The products, you get that product, and you also repeat it 10,000 times. 10,000 times is the number of test set that you have. 10,000 here is the number of test set that I have. Do you get that?
Yes, we can get you.
So I repeated the product 10,000 times and repeated the ID 21 times. So in the end, I will have a matching number of ID and product in order to do the combination, or in order to do the combination together. Do you get what I'm saying?
Yes.
So now so here is I concatenate everything together. Let me try to run this from up. So let me, So okay. So now in the if I show submission index, this is what you have. You have the ID and the product. So the IDs are repeated the number of time, the number of products that you have is every ID you have 21 of them because you have 21 products. So do you get that?
Yes, yes, we can get you.
So now the next thing to do is just to aggregate this submission index. So I want to aggregate it. How did I aggregate? So Pandas data frame has an attribute, a method, not even attribute, a method called .aggregate .agg. There's also aggregate, but .agg. So agg, you pass the function, and the function is join. I want to join. So using this like Cartesian product, this X. So I want to join, and the axis, I want to join the column together because here there are two columns, right? So I can join all the columns together. Make sure that before you use this, make sure there are only these two columns that you want to join, right? If you have more than two columns, then you can specify the columns you want to join here. You know how to specify columns in Pandas, right? So you just specify the column, maybe column 1 and maybe column 2. You can do this too. That is if you have so many columns and you only want to join column 1 and column 2, right? So this is it. But here I only have just that two columns, so I don't need to specify any column. Just join those two together. So join and rename the column ID by P code. So this is what I did. And if you print it out, it's taking forever. So if you print it out, this is what you get. So every ID is combined with every product. So also make sure that you know the order, because depending on how you are training your model, right? If you want to test now, make sure that the testing, you arrange your prediction in the way that you have arranged this ID P code. Else you just give your prediction of one to another to the other. So you have to make sure that your prediction is also in line with these ID codes. Do you get the idea now?
Yes, it's clear now.
Okay, so I think are there any other question?
Okay. Yes, I have a question. Okay, after getting the prediction probability, when I check online, some person said the first column in the prediction probability refers to the class that will be 0, and then the second one is for the class that will be 1. So
Yes.
for me, I have to use the first column. Is it correct?
No. The column that you are supposed to use, that you are supposed to submit, is the column corresponding to 1, because you want to when you do predict log probability, so you are predicting the positive class. So it is assumed that the positive class is 1. Like, if you predict if the P code is 1, that means you subscribe to the insurance thing, right? If it is 1, that means you subscribe,
yes.
right? If it is 0, that means you didn't subscribe. So what is positive and negative there? Positive to the company means that you subscribe. That's 1. So you have to take the column corresponding to 1, which is positive. So if the probability is greater than 0.5, that means that it is most likely that that person will subscribe to that product. If it is less than 0.5, that means it corresponds to 0. That means the person will not subscribe. That will be 0. So you have to take the one corresponding to the positive prediction, which is the second column corresponding to 1. That's what you submit.
Okay. You said something about log proba. Is it log proba we are doing or the
Sorry.
prediction proba?
No, not log proba. It's just proba.
Okay. Thank you.
Any other question? Okay. Someone asked if I could share the code on the discussion board on Zindi. Let me see. I have to rewrite this thing somehow, and now I don't really like writing codes that much, especially when it's involve training pandas or everything.
No, Usman.
Yes.
Yeah, it's just a formality because Zindi just said that if you are sharing code, if we are not in a team, we have to share to everyone else.
Yeah, I get the idea. One thing is let me see. This is not a complicated thing, a complicated code. So it's just let me see. You can even take a screenshot. It's fine. Just understand what is being done here. You can just take a screenshot. You get what I'm saying? So know that the ID here, I repeat the ID 21 times. So the repetition here is you can see the printout here. It repeats one after the other. You repeat all the first one, then all the second one, and so on. And you reset the index because the index will change. And I concatenate this colon. Let me just bring this out. So I concatenate this colon. So you just have to take that the column names of your Y. I get the column name of the product. So there are 21. So there are 21, and I put it as a list. You see this as a list multiplied by 1,000 because I want to create 1,000. You know, if you multiply a list by a number, what it does is it extends the list, right? So something like that. You get the idea, right? I don't really know how to explain codes. I don't know.
Yeah, I get the idea.
But if you run into any problem, just send me a message on Slack, and I'll attend to it. Okay.
Hello.
Patrick. Oh, Patrick was okay. Like you said, yeah, I can share my notebook, no problem. But one thing is, my notebook is very rough because I'm not actually participating in the competition. I'm just and even if you are participating, you don't always write a very neat code because you are trying so many things. So I'll let me see if I can Okay, I will upload it on Colab. I'll upload it on Colab, then I'll share the link. I'll share the link. So so Patrick, what do you understand by predict proba if it's not predicting the probability of the class? Jeanette, I'm going to share my Colab, then you can just go through it. I just want to warn you now, it's not that neat, so so are there any other question before we call it a day?
I could try to answer Patrick.
What I know is that it predicts the probability of the class, such that if you sum the predict proba if you sum through the rows, you get 1 1 1 1 1, right?
Yeah.
So, but what do you understand, Patrick? Maybe I don't know.
Yeah.
Patrick, can
Like
you unmute and talk, or you can type? Okay. So now,
Hello. Hello.
hello, I can hear you.
Yeah, with your SK multi-length. So how did you get the previous program using your SK multi-length?
How
Hello.
did? Oh, okay. Okay. I'm coming. Let me copy this link. So now the SK multi-learn, what it does is it will give you. So I've shared the link to the Colab. If you don't have access, let me know. Just check the link now. I think I grant everyone access. If you don't have access, let me know. So let me open. Okay. Can you please repeat the question again? You said there is a method in the SK. When you define an instance, there is a method called predict proba. So it will predict the probability for you.
What I'm asking is, hello.
Yeah, I can hear you.
Hello. No, we're having multi-class. Basically, for my own, what I did was just to have the one column. So the previous program was easier. But now that we're having multi-class, you understand, we're having different roles that person.
Okay. I get you. So one thing is, what this does is, let me start with when you are using maybe decision tree or random forest, just those. Of course, it allows multi-label, multi-class classification problem. But when you do predict proba, it will give you a list of every how do I say it? A list. Okay, how do I say this again? A list of the prediction, a list of arrays of the prediction probabilities. Do you get that? Or it's confusing?
Yes, I get.
So let me see if I can even print it out for you, so you see. I have to. Okay. All right. Just a moment. I don't know where I define this. But I can quickly. Okay, so good. So let me just change it to. So now we want to see the prediction. So now, aha. Oh, I lost my screen. Just a moment. So what's the output you get now? You can see my screen, right?
Yes, yes.
Okay. So now the output here is a list. You can see the brackets here, the first bracket here. So it's a list of arrays. So the arrays are the prediction probability of each classes under each product. So this is the first product. This is the array of the first product, and the prediction probability is what you see in those brackets. Ones and the 1 correspond to prediction probabilities of all the sets, all the test sets. What you can do is just bring one of this array out. This is one of this array, and if you check the shape, if you check the shape, so this is the prediction probability. The array is the prediction probability of all the test sets corresponding to product 1, the very first product.
Okay, thank you.
Then when you change this to 1, this is the second product, the prediction probability of the test set, and so on and so on and so on. Do you get the idea now?
Yes. Thank you very much.
So it's a list. Note that it's a list of all the products, and every array in that list is the prediction probability of each particular product of all the test data set. So that is that. And for the SK multi-learn, when you do predict probability, it will rather give you 21,000. You know, the test set is 10,000, right? And the product is 21. There are 21 products, and there are 10,000 test sets. So if you combine all these arrays together, you should have 21,000 by 2. The SK multi-learn, when you do predict probability, it will give you 21,000 as a long, it's like no, it will give you 10,000 by 21. It's a matrix. It will give you 10,000 by 21. 10,000 meaning the test sets, and 21 meaning the products. 21 columns, 10,000 rows. But is it supposed to be so? Yes, because SK multilen, the output of that is the prediction probability it will give you is the one corresponding to class 1. So instead of having 10,000 then 21 by 2 as it is in this one that I've printed out for you, it only gives you 10,000 by 21. And that 10,000 by 21 means that every test set is 21, is 10,000, and the products, they are 21, and the values in that matrix are the prediction probability corresponding to only class 1, not class 0. It only gives you class 1 because that is what you need. You want the prediction probability of the positive class, which is when someone actually subscribes for the insurance. So that is what the SK multilen prints out for you. It doesn't give you the prediction probability of class 0. It only gives you the prediction probability of class 1. Do you get that idea? That is if you want to use that library.
Hello. If I understand what you say, what you're saying is that the multi-line will just give us prediction probability for class 1.
Yes.
So and it will be in form of like it said 21,000, right? I think 21
No,
by
no, no.
1.
No, 10,000 by 21. 10 is a matrix.
Okay, that is
10,000 by
10,000 rows
21.
by 21 columns.
Yes. And that 21 columns correspond to every product. You know, you have 21
Okay,
products.
okay. Each column corresponds to the probability of predicting one for each
Yes.
product. Okay,
Yes, yes, yes.
thank you very much.
Yeah, you're welcome. So, any other question before we call it a day? I guess no more questions. So thank you very much. So we can continue on Slack if you have any
Thank you very much for the session.
any confusion. Thank you very much. Welcome. So bye. See you later.